Now we're going to multiply two rational expressions together. When you multiply rational expressions, all you're really doing is multiplying any fraction. Multiply the numerators together, multiply the denominators together. So don't try to overthink this one, just put them together on one line. Remember that there's implied parentheses when something is in its own fraction bar. So on this side we're going to put everything in parentheses, this side everything in parentheses. And your first step is going to simply be wrapping it all into one long fraction bar. And now it's just like all the other simplification problems. So you originally had two fractions, they easily merge into one, and we can proceed from here. There's two schools of thought on how to do this. One of them is to break this down into its factors so that you can easily cancel them out. Another one is to divide any terms that seem like they easily can be canceled out from the start. So I'll show you both ways. You pick the way that works best for you. We want to factor out the top. Let's start with this 8. We know that 8 is 2 times 2 times 2. So those are its smallest factors. So, or 2 cubed. X can't do much with, so we just leave that as x. 7 is a prime number, so we leave that. And y squared is as simplified as it's going to get. So on our numerator we have 2 cubed, x, 7, and y squared. On the denominator we know that 21 is 7 times 3, and those two are prime, so we'll stick with 7 times 3. Y cubed is as far as we can get it. 16 is 4 times 4, and each of those are 2 times 2, so we really have 2 to the 4th is equal to 16, and would be its prime factors. And finally an x cubed. Once you have it here, you can go ahead and start crossing out anything that you have in common between your numerator and denominator. So I see a 7 in both, get rid of that. I see an x and an x cubed, so I completely get rid of this x, and I pulled away one of them, so this 3 becomes a 2. I have a y cubed and a y squared. The y cubed is 1 larger than the y squared, so get rid of that one, and 3 minus 2 is 1. So keep that to the first power down there. I have 2 to the third power and 2 to the fourth power, so I will say that the fourth power is 1 larger than the third power. 4 minus 3 is 1, so I'll change that exponent to 1, and I'll get rid of that 2 to the third in my numerator here. And what I'm left with is 3 times y times 2 times x in my denominator, or times x squared, sorry. And in our numerator, since everything got canceled out, it's not a 0 up there, because remember we're dividing. So it's going to be just a 1 that's going to be left up on top. So we have a 1 in our numerator, and then we have 3 times our 2 to the first power, so just 2, times our y to the first power, just y, times our x squared. Now I said I would show you the other way of getting to that. What I like to do is when I have it all together like this and I see a few different constants, I see an 8 and a 16, and I know that 16 is twice as large as 8, so I'm going to cross out that 8, cross out that 16, and replace it with a 2, because I took 8 divided by 8, and that canceled out. 16 divided by 8 was 2, so now I'm left with a 2 in the denominator. Same thing here with the 21 and the 7. Cross the 21 out, divided by 7 to get 3. The 7 out, divided by 7 to get 1, so just leave it as is. I see I have one more y in the denominator than in the numerator, so I'll take that, change it to the first power, and get rid of the y squared up here. X and x cubed. X cubed is 2 more x's larger than x to the first power, so get rid of that, and change this exponent to a 2. 3 minus 1 is 2. And there's nothing left in my numerator. And my denominator, I have a 3, y to the first, 2, and x to the second, which is exactly what we ended up when we factored it out the long way. So if you feel comfortable working straight from the shortcut here, that's a perfectly acceptable thing to do. Just have to make sure that you're not making any mistakes, because this is a little bit more prone to errors. However, it results in the exact same thing. And then finally, you just multiply this out to simplify it. 3 times 2 is 6 in our denominator. Everything else we can't simplify any further, and you're left with 1 over 6yx squared. Second example over here. Again, we're multiplying, so that means that we just wrap everything in parentheses and throw it all onto one big line of one big fraction. Otherwise, there's really nothing going on. If you were super lazy, you would just take this and draw a line across, throw some parentheses, and it would be the exact same thing. I'll just write these in here. And that's exactly the same as what we have in this line below. Now, again, I'm going to show you both ways here. So let's factor this out all the way. We have a 6, which is 2 times 3. We have a x squared and a y. Leave those as is. 10, which is 2 times 5, and then x cubed y squared. So that's exactly what we got here. In our denominator, 5 is prime. We have x and y just as they are. We have 3 x, y, z, and we'll just leave those exactly as they came to us, because all of those are either prime or in its simplest form at the moment. And now let's see what we can get rid of here, what we can cancel out. Well, first of all, I see a 3. I see an x and an x, which can link up with this x squared and cancel that out, because x times x is x squared, so that was an equivalent operation. Right in front of me here, I see a y and a y, but I actually have a y and two y's in the denominator, so it's y squared, and I have a y squared term up here, so I'm going to decide to cross that one out instead. Let's see, I have a z down here, no z's up on top, a 5 down here, I do have a 5 in the numerator. Cross that out, and everything else is as simple as it's going to get. So if we move on here, we should have 2 times y times 2 times x cubed all over z. Taking the shortcut method, let's see if that works on here. I see a 6 and I see a 3. Divide both by 3, and I'm going to be left with a 2 up here, and cross that out. A 10 and a 5, I can divide both by 5, and I'm left with a 2 up here. I see an x and an x and an x squared, so I'm going to get rid of those. I see a y and a y and a y squared, so I'm going to get rid of those. And that's as far as it can go. Again, 2y, 2x cubed, 2y, 2x cubed, all over z. So same result. In this, you just multiply it together. 2 times 2 is 4, and the rest will stay as variables. So 4yx cubed over z. Last two examples here. We have x minus 3 over x plus 2 times x squared plus 5x plus 6 all over x squared minus 9. First step is simply wrapping things in parentheses and putting it into one fraction. So we'll just rewrite it like this. Once we have it here, though, there's nothing that cancels out. So we need to do some factoring in order to find terms that are multiplied together that are the same in the numerator and the denominator. So in our numerator, x minus 3, you can't factor that any farther. That's as far as it's going to go. So we'll leave that. X squared plus 5x plus 6. So that's just unfoiling. So we're just looking for something that multiplies to 6, two numbers that multiply to 6 and add up to 5. So in this case, 1 and 6, not going to work. 2 and 3 multiply to 6, add to 5. We're going to get x plus 2 and x plus 3 as our two factors on top. And that was just simply taking this here and turning it into these two factors here. In our numerator, we have x plus 2, nothing we can do with that. Just leave that as is. X squared minus 9, smells very much like a difference of squares, x squared minus 3 squared. So the way that difference of squares factors is always the first term plus the second term and the first term minus the second term, where I'm looking at the bases. So since 9 is 3 squared, we end up with x plus 3 times x minus 3. If you were to FOIL this out, you would get x squared minus 9 back. So I'll just highlight this to remind you where this came from. But once you get it to this stage here, you can simply look at, okay, what factors in my numerator and denominator cancel out, because all of the things, groups of parentheses are all multiplied next to each other. So x minus 3, x minus 3, x plus 3, x plus 3. Oh my goodness, look at that. The beauty of mathematics has just been shown to you. We're left with 1 over 1. Simply 1 would be our answer for this messy fraction here. Finally, last example. We have 4x over x plus 5 times 3x plus 15 over 12. First step, we're pretty used to this, wrap it in parentheses. So you just throw your parentheses around it so it's one big term that you need to simplify. Second step, we need to factor anything we can, because we don't have anything in common right now that we can easily cancel out. So we need to factor this down. In the numerator, I see that 3x plus 5, or 3x plus 15, I can pull a 3 out, so that is x plus 5 times 3. So I'll go ahead and do that. And for the purposes of factoring things down, I took my 2 and broke it down to 2, or my 4 and broke it down to 2 times 2. So, like I said, I pulled that 3x plus 15 and turned it into 3 times quantity x plus 5. So that's equivalent. In my numerator, not much I could do except break up my 12 into its factors, 2 times 2 times 3. So that way we have our factors down here. Let's go ahead and start canceling things out. I see a 2, I see a 2, another 2, another 2, 3 and a 3, x plus 5, look at that, comes down to just x. So that's the beauty of factoring these things out. You start to find lots of things in common in the numerator and denominator. Now granted, this is not always going to work out as cleanly as they do in the example problems I came up with for you. However, in many problems, they will simplify quite a bit from what you started with. So do look for some of that.